assume that you are a city planner. Now there are two communities, Y and Z, and there's a road that connects these two communities. Now what they wanted was, the two communities, they pooled in funds to make a swimming pool. So now you want to make this swimming pool. So the question is, where would you make this swimming pool? Obviously, if you make the swimming pool here, it would be closer to Y than Z, and hence unfair, because both of them have contributed equal money. So the pool, the swimming pool, should be made at such a point so that it is equidistant from Y and Z. That is, its distance from both the points should be the same. Only then it would be fair for both of them. So now the question boils down to, where should I make this swimming pool? Where? Okay. So all I need to do is, I need to find points such that they are equidistant from Y and Z. Both Y and Z. So for this, recall perpendicular bisector. Let's recall what perpendicular bisector was. So perpendicular bisector, basically, if you bisect a line segment, let's say the line segment is BC, and you bisect it perpendicularly. So this line is perpendicular, as well as it bisects this BC, segment BC, then I can say that this line is perpendicular bisector to these 2 points. So now let's say that the point D lies on the side B and C. This lies on the line BC. So D is obviously a midpoint to BC. BD would be equal to DC. But not just point D. In fact, if I take any point on this line, if I pick any point on this line, which is the perpendicular bisector, then the distance of this point from both these points of the line segment would be the same. That is, this distance would be equal to this distance. In fact, let's take different points on this line, which is the perpendicular bisector to BC. Distance of all these points from B and C would be the same. So this would be equal to this. Similarly, if I call this point E, then BE would be equal to EC. And let's say if this point is F, then BF would also be equal to FC. So a perpendicular bisector is a line on which you can take any point, and that point would be equidistant from the vertices of the line to which it is a perpendicular bisector to. So this is what I get from perpendicular bisector. Now let's try to apply this to the problem. So this is exactly what my problem was. I had these two communities and I wanted points which would be equidistant from both. So what I can do is draw a perpendicular bisector. So if I draw a perpendicular bisector, now any point on this line, this is the midpoint. Let's say this point is A. So YA would be equal to AZ, midpoint. Similarly, but you cannot make this swimming pool here because there's a road that goes by joining Y and Z. So it has to be away from the road. So now any other point on this line, this point, this point, this point, this point, any point on this line which is the perpendicular bisector would be equidistant from both Y and Z. So the problem is solved. Now you can make this swimming pool at any of these points. But before you could make this swimming pool, the third community comes up. So there's this third community which is X, and now they also wanted a swimming pool. So what they decided is, X, Y and Z, all the three communities decided to put an equal amount of money to get this swimming pool constructed. Now what do? I want to make this swimming pool such that it is equal to X, Y and Z. All the three communities, since all of them are contributing equal money, so I need to make the swimming pool such that it is equal from all the communities. The distance is equal from all the communities. Now I have these three non-collinear points, and I know that three non-collinear points always gives me a triangle. So I have this triangle. Now it boils down to finding a point in this triangle such that the distance of that point from each of these communities is the same. I know that if I draw any point on this line, which is the perpendicular bisector of YZ, then any point on this line would give me equal distance from Y and Z, both Y and Z. So similarly, now I want to make the swimming pool such that it is equal from both the communities Y and X also. Not just Y and Z, but it should be equal for Y and X and also for X and Z. So what I do is, I draw a perpendicular bisector to YX. Let's say this is the perpendicular bisector to YX. Since it's a perpendicular bisector, it is perpendicular and it is bisecting the sides also. Now any point on this line would give me equal distance from both Y and X. So this distance would be equal to this distance. And that holds true for any point that is on this line. Now this point, let's look at this point. This point lies on this yellow line, which is the perpendicular bisector of YZ, and this red point also lies on the orange line, which is the perpendicular bisector of YX. So since it lies on the perpendicular bisector of YZ, it would be equidistant from Y and Z. But since it also lies on the perpendicular bisector of YX, it should be equal from Y and X. So I get that this distance should also be equal. So now what I see is that this point is actually equidistant from Y, X and Z. Now let us see whether if I draw a perpendicular bisector to X and Z. Why do I draw a perpendicular bisector? Because I want all such points which are equidistant to X and Z also. So let me draw a perpendicular bisector to this side and see whether it intersects at this point or not. So I draw a perpendicular bisector here and I see that all these three lines are intersecting at one point. So they all are intersecting at this point. Now this point lies on all the three lines. This line and this line. So this point lies on the perpendicular bisector of each side, and hence I can say that this point would be equidistant from all 3 points. So let's look at this point. This point should be equidistant from X, from Y and from Z. So I can make my swimming pool at this point, and we can see that this point is actually equidistant from all the 3 communities. So that's how I can solve my problem. But now the question remains that what is this point? What is actually this point? So let us take a triangle ABC. Let's take this triangle and draw perpendicular bisectors to each side. So we draw perpendicular bisectors to each side. So since they are perpendicular bisectors, not just bisecting, but they would also be perpendicular. I see that all these perpendicular bisectors are meeting at one point. They intersect at a point. Let's call this point D, and this point where all the perpendicular bisectors intersect is actually called the circumcenter. Now why is it called the circumcenter? Let's see. We know that this point D is the circumcenter. In fact, this point D is such that it is equal from all the 3 vertices A, B and C. Now with this as center, the D as point D as the center, and AD, DC or BD as the radius, I can actually draw a circle around this triangle. I can draw a circle around this triangle, and this circle is called circumcircle. Circum means around, so a circle which is around a triangle is the circumcircle, and this point D is the center. So why circumcenter? Because it is the center of a circle which is circumscribed around this triangle. So it is the center of a circumcircle, so it is called the circumcenter. So we see that a the point of intersection of three perpendicular bisectors is called circumcenter. And you can obviously draw a circle with this center and either of these as the radius. The distance of this center from A, B or C from each vertex, if you take that distance as your radius, then you can actually draw a circle around this triangle, which is called as the circumcircle. Now let us look at this triangle. We see that these are the three perpendicular bisectors and they all are intersecting at one point. So this is a right triangle and I see that the circumcenter is actually coming at one of its edges. From right triangle I make an obtuse triangle. The circumcenter actually moves outside the triangle. So it is not necessary that this circumcenter is always inside the triangle. You can have the circumcenter outside the triangle also. As long as the perpendicular bisectors are intersecting at a point, that point is the circumcenter. Circumcenter is actually the center of a circle which is around this triangle. So it is the center of a circumcircle. So you can see that for any triangle, you can get the circumcenter by drawing perpendicular bisectors and finding the point where they intersect. And with this point as the center, you can make a circle around the triangle also. So even if you try to move this triangle or make any triangle, you will see that you would always get a circumcircle. So even if the circumcenter is outside, you can make a circle that touches all the points of this triangle, circumscribes it, or whether it's inside, you can always make a circle. For every triangle, you can make a circle that just touches the triangle, the vertices of the triangle, circumscribes this triangle, and we call that circle as circumcircle. The center of this circle is called as circumcenter, and this center is nothing but the point where all the perpendicular bisectors intersect.